In this video, we will learn how to do electronic configuration as PDF of element. So before knowing about this, the thing you have to know is about shells, that K, L, M, N are shells. And each of these shells have its own particular subshell. So starting from the first K, it has one subshell that is 1s. Now the second L has two subshells, 2s, 2b. Now the third one M has three subshells, 3s, 3b, 3d. And the last one 4 has four subshells, 4s, 4b, 4d and 4f. Now I'll make you understand how to do electronic configuration. So the very thing is that we have to draw an arrow like this. Okay. Now here is a trick that how you can do the electronic configuration. So we will start from the first arrow, means the tip of first arrow, that is here. So this starts from 1s. So every time the first electron, okay, it will be in 1s. Then we will look at the second arrow, okay. So the second arrow is here, this 2s one. So as we know that the first one was in 1s, now the second will be in 2s. Now we will look at the third shell, that is the first one is 2p, so we will write 2p and the next is 3s. Now come to this arrow, the first one is 3p and the next is 4s. So in this way we are doing the electronic configuration. But the very thing that you have to know is that how many shells, how many electrons can a particular shell hold. Like S that we have right here can hold 2 electrons. This P can hold 6 electrons. D can hold 10 electrons and F can hold 14 electrons. Okay, you have to remember this thing. Now what we will do is that we will do the electronic configuration of some elements which would make it possible for you to do the electronic configuration of other elements. So starting from hydrogen, okay, we will first do the electronic configuration of hydrogen. Now as we know that the atomic number of hydrogen is 1. So its electronic configuration will start from 1s. So first of all we will write 1s. So we have to plot the electrons here, okay, here in the superscript. Now as we know that how many electrons it has 1 electron, so we will put that one here. This is the electronic configuration of hydrogen. It's quite easy, right? Now we will do the second electronic configuration, that is of helium. Now we have to know that how many electrons are there in helium. It has 2 electrons, means its atomic number is 2. Now we will again write 1s2. 1s2. But this time remember that what is the atomic number of helium? That is 2. So we will write 2 over here and this is complete. Now we will do the electronic configuration of third element, that is lithium. Its atomic number is 3. Now here is a little bit change in its electronic configuration, because the first of all what we will do is that we will write 1s2. Now here you can see that this first arrow over here is complete. So we will move to the second arrow, and the starting of second arrow is from 2s. Now we will write 2s here. Now we don't know how many electrons are there on the superscript of this 2s. So as we know that the atomic number of lithium is 3, 2 electrons are here on the top. We will write -2 and the remaining is 1. So we have to plot only 1 electron on 2s2. Okay, so we will write 1. So this is how we can do the electronic configuration. Now we will do the electronic configuration of few other elements so that it will be easy for you to do the electronic configuration of the rest of them. Now let's suppose we will take an example of neon. Okay, so we have an element that is neon. So the first of all, the thing we know is that its atomic number is 10. So we will start from 1s, 2, 2s, 2. Now what is the next subshell? That is 2p. Okay, so we will write 2p here, and you know that p can hold 6 electrons, as it is shown here that the maximum number of electrons that p can hold is 6. Now we don't know how many electrons will come here, so we will do a calculation that the atomic number of neon is 10. Okay, so we have 2 electrons on 2, 1s2, 2 on 2s2. Now this is 2 plus 2, 4. Now 10 minus 4 is 6. So from here we have come to know that the number of electrons on 2p will be 6, and 6 is also the maximum number of electrons it can hold. Now we will do the electronic configuration of next element, that is magnesium, and as we know its atomic number is 12. So we have here magnesium whose atomic number is 12. So we will write 1s2, then 2s2, 2p, 6. Now after 2p we have 3s. Okay, so now we will move to 3s, and from here you can easily see that as the atomic number of magnesium is 12, so 2 plus 2, that is 4, plus 6, that is 10. Now how many electrons are remaining? 2 electrons are remaining. So we will write those remaining electrons on 3s2. So here it will be 3s2. So in this way, how we can do the electronic configuration. So I hope it has been a useful lesson.